Welcome to Listen and Imagine, the YouTube channel where mysterious stories, hidden truths, and mind-bending ideas come to life through captivating narration. The universe is a giant brain. The universe is a giant brain. Part 1. Is the universe thinking? Have you ever looked up at the stars and felt like something was looking back? Not a god, not an alien spaceship, but something bigger, something older, something thinking. It's a strange question, I know, but tonight I want to ask you something that might change how you see the entire universe. What if the universe itself is a brain? Not metaphorically, not poetically, but literally a vast living, thinking structure spread across billions of light years, a cosmic mind pulsing with information. And you and I, just tiny sparks flickering somewhere deep inside its neural web. It sounds crazy, right? But by the end of this episode, you might start to wonder, what if it's not so crazy after all? Let's begin. 1. The cosmic mirror. We humans tend to believe our brains are the most complex structures in the universe. 80 billion neurons, each connected to thousands of others. A tangled web of impulses, memories, emotions, and thoughts. But have you ever seen a map of the universe? Not just stars, I mean the cosmic web, the large-scale structure of the universe. Filaments, nodes, voids, billions of galaxies spread out in a sprawling pattern that eerily resembles a neural network. Now here's the kicker. In 2020, a team of scientists from the University of Bologna, Italy, published a study comparing the structure of the universe to that of the human brain. Their conclusion? The distribution of galaxies in the cosmic web is mathematically almost identical to the structure of neurons in the human brain. Let that sink in for a moment. 2. Coincidence or code? So here's the question. Is it just coincidence, or is there something deeper? Something designed? Let's talk numbers for a second. Your brain has roughly 80 billion neurons. The observable universe, estimated to contain around 100 billion galaxies. Each neuron connects to thousands of others through what we call synapses. Each galaxy connected to others by vast filaments of dark matter, gravitational threads stretching across space. Sound familiar? Both systems, brain and universe, use about 30% of their mass for nodes and connections, the rest being so-called background noise or unused mass. Why would two completely unrelated systems, one inside your head, the other spanning the cosmos, follow the same structure? And if they do, is it really unrelated? 3. If it walks like a brain. Let's play a thought experiment. Let's say you were an alien, or better yet, an intelligence beyond our universe, and you stumbled across two data maps, one of a human brain, the other of the cosmic web. Would you be able to tell them apart? Think about this. If two things look the same, act the same, and function in similar ways, do we not, in science, often consider them equivalent? So here's a bold idea. If the universe is built like a brain, maybe it functions like one too. 4. The theory of a thinking universe. This idea, the thinking universe, isn't new. In ancient times, philosophers like Plato and Anaxagoras spoke of a cosmic mind, or nu, the intelligence behind the fabric of reality. Modern versions of the idea are re-emerging, not just in fringe science, but from respected physicists and neuroscientists. The idea has names. Panpsychism, the belief that consciousness is a fundamental feature of all matter. Integrated information theory, which suggests that any system with a high degree of interconnectedness can be conscious. Your brain qualifies. So does the internet. But what if the entire universe qualifies? 5. So, where's the evidence? Let's dig deeper into the 2020 study from Bologna. Physicist Franco Vazza and neurosurgeon Alberto Folletti ran a comparison between a section of the human cerebellum and a simulated slice of the cosmic web. They didn't just eyeball it, they ran statistical analyses. They found that both structures shared the same clustering behavior, node connectivity, and even information density. Despite the scale difference, one at a millimeter, the other at millions of light years, the complexity and behavior were nearly identical. That's not just poetic symmetry. That's data. 6. A new kind of consciousness? Okay, so maybe the universe looks like a brain. But what about function? Let's break down how the brain works. At a basic level, it collects inputs, sensory data. It processes those inputs. Then it generates output, decisions, actions, thoughts. Now imagine this. Could galaxies be input centers? Could black holes be processing units? Could dark matter, the mysterious 85% of mass we can't see, be the information highway? Could the universe be running calculations? 7. Is the universe aware of us? Here's where it gets wild. If the universe has a brain-like structure, if it's capable of processing, if it's connected like a neural net, could it be aware of itself? Could it be aware of you? Carl Sagan once said, "We are a way for the cosmos to know itself." What if he was being literal? What if human consciousness, your thoughts, your memories, this very moment is part of the universe self-awareness, not separate from it, but part of its mind? 8. The scary part or the beautiful part? If the universe is a brain, then where do we fit in? Are we individual neurons, tiny bursts of thought, random firings in a giant skull of stars, or are we something more? And here's a chilling thought. What if we're not at the center of this mind, but just a small corner of it? What if we're the dream, and the dreamer is something we can't even comprehend? 9. So now what? What does this all mean? Maybe nothing. Maybe this is all coincidence, or maybe, just maybe, we've been looking at the universe the wrong way. Maybe it's not just a place. Maybe it's not just space. Maybe it's a system, a self, a consciousness so vast it takes billions of years just to finish a single thought. And we, you and I, are little sparks in the middle of that thought. 10. One last question. So let me leave you with this. If the universe is a brain, then whose mind are we living in? Are we part of something divine, something alien, something natural, or something we've never even imagined? And more importantly, what happens when it wakes up? End of part 1. Stay tuned for part 2, Neural Networks and Galactic Webs, where we dive deeper into the mathematical similarities between your brain and the universe. The universe is a giant brain, part 2, the cosmic neural network. Opening. Close your eyes. Now imagine this. Every star in the night sky, every swirling galaxy, every thread of dark matter, all of it is thinking. Not in a metaphorical way, but literally. In part 1, we proposed a bold idea, that the universe may not just resemble a brain in structure, but maybe a brain in function. So the question now is, if the universe is a brain, then where are its neurons? Let's take a deep dive into the structure of the cosmos and see how disturbingly close it mirrors our own mind. Section 1, Neurons versus Galaxies, a startling comparison. In 2005, a physicist named Franco Vazza and a neuroscientist, Alberto Folletti, did something unthinkable. They compared high-resolution simulations of the universe with scans of a human brain. What they found? Despite being different in scale by a factor of 1027, the structure of the observable universe and the neural network of the brain are almost identical in form. The brain has roughly 86 billion neurons. The universe, roughly 100 billion galaxies. In both systems, these individual units, neurons and galaxies, connect through long filaments, synapses in the brain, cosmic filament in the universe. And the ratio of matter to void, strikingly similar. So here's the question. Is that just coincidence? Or is it evidence of a deeper truth? Section 2. Filaments and synapses, the pathways of thought. If the brain thinks through synaptic connections, could the universe think through cosmic filaments? Cosmic filaments are vast threads of matter, sometimes billions of light years long, connecting clusters of galaxies. They form the cosmic web, a structure scientists believe governs the expansion and distribution of the universe. But what if they do more than that? In our brains, electrical impulses travel through neurons via synapses. In the universe, light and gravitational energy move through filaments. Could these filaments be more than just highways for matter? Could they be information highways? Here's the chilling part. Recent studies show that the density and energy distribution in cosmic filaments mirror the way synaptic activity behaves in an active brain. So ask yourself, are we just watching gravity at play? Or something trying to communicate? Section 3. Consciousness at scale. Let's zoom out, way out. Some scientists, like physicist Max Tegmark, argue that consciousness isn't just a biological phenomenon. It might be a mathematical structure. Something that emerges naturally when complex systems form certain patterns. And what's more complex than the universe itself? Tegmark calls it perceptronium, a hypothetical substance that can perceive, process, and respond to information. Sound far-fetched? Well, consider this. A single neuron is just a cell, but billions of neurons together, they wake up as a mind. So couldn't billions of galaxies connected through the cosmic web act like a cosmic brain? Maybe consciousness isn't limited to skulls and spines. Maybe the universe is already aware, in a way so vast we can't even comprehend it. Section 4. The role of dark matter and energy. Here's the mind bender. Over 95% of the universe is made of stuff we can't even see, dark matter and dark energy. We know it's there because galaxies spin faster than they should and the universe is expanding at an accelerating rate. But what if that dark matter isn't just background noise? What if it's processing something? Some scientists speculate that dark matter might act as a hidden framework, like scaffolding, that allows the rest of the universe to function smoothly. Others go further, suggesting it could act like neural glue, holding together galactic thoughts in the same way that glial cells hold together our neurons. If that's the case, maybe we've been trying to understand the universe as a machine when it's actually a mind. Section 5. Simulations, Signals, and Synchronicity. Now here's where it gets really weird. In 2012, a group of physicists suggested that we might be living in a simulated universe, and that the structure of reality could reflect the code of its creator. But what if the simulation isn't running on a computer, but on itself? If the universe is a self-contained conscious system, maybe it doesn't need a server. Maybe it's its own server. And there are whispers, strange, unexplained radio signals from deep space, known as FRBs, fast radio bursts, that seem to defy natural explanation. Could these be the neural firings of a cosmic mind? Could they be messages, not from aliens, but from the universe itself? Ending. So now we've seen the strange parallels. Neurons and galaxies, synapses and filaments, thought and expansion, brainwaves and cosmic energy. If the universe really is a brain, what is it thinking about? Does it know we're here? Are we part of its thoughts, or just noise? And here's the biggest question of all. If we are neurons in a universal brain, what happens when we finally make contact? Not with aliens, but with ourselves on a galactic scale. Are we ready? Or are we still too small to understand what we're truly a part of? Stay tuned for part 3. Signals from the Void. Is the universe trying to speak? The universe is a giant brain. Part 3. Signals from the Void. Is the universe trying to speak? Opening. What if we've been listening to the universe all wrong? What if all those strange signals, the bursts of radio waves, the flickers of distant light, the background hum of space, aren't just cosmic noise, but communication? In part 2, we explored the unsettling similarities between the structure of the brain and the universe. The patterns, the connections, the energy flow, all pointing toward the possibility that the cosmos might not just be like a brain, it might actually be one. But a brain isn't a brain unless it's thinking, and thinking leaves traces. So the real question is, what if the universe has been trying to talk to us all along, and we just didn't know how to listen? Section 1. Fast radio bursts. Brainwaves of the cosmos? Let's start with one of the most puzzling cosmic mysteries of our time. Fast radio bursts, or FRBs. Discovered in 2007, FRBs are incredibly powerful, ultra-short bursts of radio energy. They last just a few milliseconds, yet they release more energy than the sun does in days. And here's the kicker. We have no idea what causes them. Some of them repeat. Some are one-time only. Some come from the edges of the known universe. And while scientists have proposed explanations, magnetars, quasars, black hole mergers, none of them fully explain the timing, frequency, or power of these signals. So here's a radical thought. What if FRBs are the neural firings of a conscious universe? Imagine, just as our brain generates measurable waves, delta, theta, alpha, the universe might emit macro-scale brainwaves, and we're just now beginning to detect them. Could FRBs be thoughts? Or even messages? Section 2. The cosmic microwave background, a whisper from the beginning. There's a faint glow across the sky, a remnant from the very birth of the universe. It's called the cosmic microwave background, CMB. We've mapped it, we've measured it, we've turned it into stunning 3D models. But what if we've misunderstood it? Physicist Julian Barber once theorized that time might not exist as we think it does, that the universe exists as a series of static frames or snapshots, and our consciousness simply moves through them. Now, overlay that idea on the CMB. Could the faint hum of the early universe be a foundational memory, a recorded signal like a brain's first impulse, still echoing across time, or even wilder? Could it be a kind of cosmic dream, a memory the universe plays over and over to keep itself anchored? Section 3. Quantum signals. Thought at the smallest scale. Let's get microscopic. In the brain, thought emerges from quantum interactions between molecules, ions, and proteins. A theory supported by researchers like Roger Penrose and Stuart Hameroff, who proposed orchestrated objective reduction, OR. They believe consciousness arises from quantum processes within neurons, specifically in microtubules, the protein structures that support cell shape. Now apply that idea to quantum fields in space. What if the vacuum of space isn't empty at all, but full of fluctuating quantum information? In this view, quantum entanglement, the phenomenon where particles affect each other instantly across vast distances, could act like instant messaging between different parts of the universe. What if these are thoughts connecting? What if entanglement is awareness? Section 4. Patterns, pulsars, and possible code. Let's talk pulsars, those spinning neutron stars that emit beams of radio waves at perfectly timed intervals. Some pulsars are so regular, they rival atomic clocks in their precision. Now ask yourself, what kind of natural object operates with that level of mathematical discipline? When pulsars were first discovered in 1967, they were nicknamed LGM, for little green men, because their signals were so structured that scientists thought they might be artificial. That theory was dismissed quickly, but maybe we shouldn't have let it go so easily. Some researchers, like astrophysicist Gregory Benford, suggest we should revisit this idea. Not looking for alien civilizations, but alien intelligence on a cosmic scale. Could the pattern of pulsars, when analyzed correctly, reveal a kind of code? Is it possible that the universe is emitting a baseline signal, like a nervous system constantly firing to maintain awareness? Section 5. Consciousness feedback loops. Are we the signal? Now here's a twist. If the universe is conscious, and we are part of the universe, then that means we might not just be receiving signals, we might be sending them. Every human thought, emotion, and action is a burst of electrical and chemical activity. Multiply that by billions of minds over thousands of years, and the energy becomes significant. Now imagine if the universe is capable of sensing this activity. Could our collective consciousness be feeding into the universe's larger mind? Could prayer, meditation, emotion, even intention create feedback loops that affect cosmic reality? This isn't just spiritual speculation. It's backed by cutting-edge research into the Global Consciousness Project, which claims that large-scale human emotion correlates with changes in physical systems, like random number generators, across the planet. So what if the universe isn't just broadcasting? What if it's listening? Ending. The deeper we go, the weirder it gets. FRBs that pulse like thoughts. Quantum fields that fluctuate like neurons. Pulsars that tick like logic gates. A background hum that sounds eerily like a memory. And us, thinking, wondering, questioning. Perhaps the synaptic spark that gives the universe its own form of self-awareness. But if the universe is a brain, if it is thinking, what does it think of us? Are we part of the message? Or are we just beginning to learn how to reply? Stay tuned for part 4. Dark matter as memory. Is the universe storing information? The universe is a giant brain. Part 4. Dark matter as memory. Is the universe storing information? Opening. What if everything, every moment, every atom, every thought is being recorded? What if the universe doesn't just remember through physical scars like supernova remnants or black hole trails, but through a systematic structure we don't yet fully understand? We've talked about signals, about possible thoughts, and even communication across quantum space. But now let's push further into the shadows. Let's talk about the dark side of the universe. Not evil, not sinister, but truly physically dark. Dark matter, it makes up 27% of the universe. We can't see it, we can't touch it, we don't know what it is, but we know it's there. And if the universe is a brain, then maybe dark matter isn't just filler. Maybe it's memory. Section 1. What we think we know about dark matter. Let's get our cosmic bearings. Dark matter was first theorized in the 1930s when astronomers noticed galaxies weren't behaving as expected. Based on visible matter alone, they should have been spinning apart. But they weren't. Something was holding them together. Something invisible, yet massively influential. We called it dark matter. Later, in the 1970s, Vera Rubin's work confirmed that galaxies are surrounded by halos of this invisible substance, and without it, the cosmic structure we know wouldn't exist. In short, dark matter is the glue that holds the universe together. But here's where it gets weird. We can't detect it directly. We don't know what particles it's made of. We don't know if it interacts with normal matter or if it just exists beside it, almost like a ghost infrastructure, or maybe more accurately, a hidden archive. Section 2, memory in the brain versus memory in the cosmos. Let's bring it back to the brain. In your mind, memory isn't just about neurons, it's about patterns of connection. It's not the firing itself that stores a memory, but the pathways, the reinforcement, the architecture. Could dark matter be doing the same? Imagine that dark matter is to the universe what neural networks are to the brain. It doesn't glow, it doesn't explode, but it connects, it stores. And it may provide the long-term stability that allows the visible universe, like short-term consciousness, to flash and change and evolve, while the real records are stored silently beneath it all. Some physicists now speculate that dark matter may be linked to extra dimensions, hidden forces, or entangled fields. Could it be a medium for cosmic memory? A storage system for information about every particle, every interaction from the Big Bang until now? Section 3, the holographic principle. Information never dies. In 1997, theoretical physicist Juan Maldacena proposed something radical, that our universe might be a hologram, not in the Matrix sense, but in the idea that all the information inside a volume of space, like a galaxy or your body, can be encoded on its boundary. This idea is supported by work from Leonard Susskind and Gerhard Hooft, and it's known as the holographic principle. It suggests that information is never lost, even inside black holes. Now tie this back to dark matter. If dark matter forms a scaffolding around galaxies and if information can be stored at boundaries, could dark matter halos serve as giant hard drives? Could they encode the evolution of galaxies, the interactions of matter, even the emergence of consciousness? Section 4. Dark matter distribution and memory mapping studies using gravitational lensing, the way light bends around massive objects, have revealed that dark matter isn't randomly distributed. It forms a cosmic web, a structure that eerily resembles, you guessed it, the neural network of the human brain. Each node, a galaxy cluster, each filament, a superhighway of invisible mass. Could the pattern of dark matter reflect a deeper order? Just as certain areas of the brain specialize in language, memory, or emotion, could different regions of this cosmic dark matter network specialize in different kinds of cosmic functions? And if so, is there a region of space where the universe stores its equivalent of long-term memory, a place where the history of existence is archived? Section 5, conscious memory or passive data? Let's pause here and ask a bigger question. Even if dark matter does store information, is it passive or active? A hard drive is passive. A brain is not. So is dark matter a recording device, or is it an active memory system capable of reaccessing, replaying, or even modifying data? Consider this. If the universe is evolving, changing its own constants, spawning life, creating complexity, then it must be learning. And learning requires memory, memory that adapts, that grows, that responds. Could dark matter, invisible, undetectable, and stable over billions of years, be the substrate for this memory? A kind of cosmic hippocampus storing the history of thought, motion, intention? Ending, we live in the light, but the truth may lie in the dark. Dark matter surrounds us. It shapes the stars, it cradles galaxies, it holds reality together. And yet, we don't know what it wants. We don't know if it's silent by nature or silent because we haven't yet asked the right question. Could dark matter be the universe's memory bank? Could it be the space where time and thought converge? And most importantly, if we learn to decode it, what might we remember? Or what might it remember about us? Next time in Part 5. Black holes as processors, are they the universe's thinking engines? The universe is a giant brain. Part 5. Black holes as processors, are they the universe's thinking engines? Opening, we've all heard the phrase, nothing escapes a black hole. Not light, not time, not information. They're cosmic monsters, devourers of matter and energy. But what if we've misunderstood them completely? What if black holes aren't the end of something, but the beginning of something deeper? In this theory, that the universe is a giant brain, we've explored how dark matter might act as memory. But memory alone doesn't make a mind. You need processing power. You need computation. And in the universe, nothing crunches data more dramatically, more mysteriously, more powerfully than black holes. So today we ask the unthinkable. Are black holes not just destroyers, but cosmic processors? Could they be the thinking engines of the universe itself? Section 1. The Black Hole Basics. Let's get grounded for a second. A black hole forms when a massive star collapses under its own gravity. The result? A singularity, a point of infinite density where space and time as we know them break down. Surrounding that is the event horizon, the point of no return. Once you cross it, you're not coming back. But here's the weird part. Black holes are simple, in a way. According to the no-hair theorem, they can be completely described by just three properties. Mass, charge, spin. That's it. Everything else, whatever fell in, is supposedly erased. But physicists aren't so sure anymore because according to Stephen Hawking and others, information can't just disappear. That would break the laws of quantum mechanics. So now the question becomes, if black holes don't destroy information, what do they do with it? Section 2. Black holes store information. But how? Here's where mind-bending. In the 1970s, Stephen Hawking discovered that black holes emit tiny amounts of radiation, now called Hawking radiation. Over time, they could even evaporate. But if they vanish, what happens to the information they swallowed? Cue the black hole information paradox, one of the biggest unsolved mysteries in physics. Many now believe that black holes don't erase information. Instead, they store it, possibly on their event horizon, like a holographic shell. This idea connects directly with the holographic principle we discussed earlier, that all the data inside a space can be represented on its boundary. If that's true, then black holes aren't just cosmic trash compactors, they're storage devices. But even more intriguingly, they might also process that information, not just store it, use it, like a cosmic CPU. Section 3. Black holes and the laws of computation. Let's take a moment to ask a wild but serious question. Can black holes compute? In 2000, physicist Seth Lloyd proposed something extraordinary. Black holes might be the fastest possible computers in the universe. Why? Because of their extreme energy density, compactness, and ability to manipulate information. Lloyd estimated that a single black hole could perform 10 SAN operations per second, a number so huge it makes today's supercomputers look like pocket calculators. Now, combine that with the number of black holes in the universe. Billions, maybe trillions. Is it so crazy to imagine that the universe has a decentralized processing network? One where each black hole is an active node, computing, sorting, and restructuring data? Just like a brain doesn't store and process in the same place, could the universe use dark matter as memory and black holes as processors? Section 4. Are black holes conscious? Let's take a bold step further. We know black holes process energy, space, time, maybe even information. But could they do more? Could they be aware? Let's be clear, we're not talking about a thinking black hole in the cartoon sense. No eyes, no voice. But think of how neurons work. They take input, process it, send output. Now think of how a black hole works. It takes in matter, light, and information, compresses it beyond recognition, releases radiation or gravitational waves in response. It fits a basic definition of input-output processing. And in neural networks, both biological and artificial, enough of those units working together lead to emergent behavior, patterns, awareness, decision-making. So the question becomes, could a network of black holes spread across the cosmos represent a kind of distributed consciousness? Not a human one. Not even a life-based one, but a cosmic awareness emerging from billions of processors working in unison? Section 5. Evidence and emerging theories. All right, let's ask the hard science question. Is there any evidence for this? Well, nothing conclusive yet, but some theories point in fascinating directions. Loop quantum gravity suggests space itself is made of information. Black holes may be the places where that information is most densely packed. In 2019, researchers using LIGO detected gravitational waves from black hole mergers, not just massive energy events, but possibly data transfer moments. A 2022 paper from physicists at Stanford proposed that black holes may act as quantum error correcting codes, preserving and organizing information just like a thinking system. And then there's the ADS-CFT correspondence, a theory in string theory that directly links gravity and information processing at the edges of space-time. In all these models, black holes aren't just endpoints, they're active elements in a larger informational structure. just like processing units in a brain. Ending. So what do we make of all this? Black holes are still the most mysterious objects in the known universe. But maybe they're not monsters. Maybe they're not even mistakes of nature. Maybe they're necessary. Maybe the universe needs black holes, not just to shape galaxies, but to organize information, run calculations, and drive evolution at a cosmic scale. And maybe, just maybe, they're thinking. Not like you or me, but in a way we're only beginning to imagine. So here's the final question for this chapter. If black holes are the processors, and dark matter is the memory, then who or what is doing the thinking? Or could the universe itself, in its totality, be the thinker? Next time in part 6, synapses between stars, are galaxies the neurons of the universe? The universe is a giant brain. Part 6, synapses between stars, are galaxies the neurons of the universe? Opening. Have you ever looked at an image of the cosmic web? Not just stars, not just galaxies, but the structure of the universe itself? It looks eerily familiar. Long strands of glowing matter stretching across the void, filament-like connections linking brilliant clusters. It doesn't look random, it looks organized, it looks like a brain. In fact, when scientists compared the structure of the observable universe to a human neural network, they found shocking similarities, not just in appearance, but in mathematical structure. So today, we go deeper into this theory. If dark matter is memory and black holes are processors, then what role do galaxies play? Could galaxies be the neurons of this cosmic mind? And if so, are stars and planets just byproducts of thought? Section 1, the cosmic web, a universal neural map. Let's start with what we can observe. Galaxies don't float randomly in space. They form clusters, filaments, and voids. This large-scale structure is called the cosmic web. It's made of galaxies, intergalactic gas, dark matter, gravitational connections. In 2020, a group of Italian and Indian researchers compared high-resolution simulations of the cosmic web with scans of the human brain's cortical network. The result? They found nearly identical connectivity patterns between neurons and galaxies. We're talking about the distribution of nodes, the density of links, the flow of energy and matter. Different scale, same shape. Now pause and think. That's like looking at a snowflake through a microscope and then seeing the same pattern in the wings of a butterfly. Coincidence? Or recurring architecture? A pattern that nature repeats from micro to macro because it works. Section 2. What do neurons actually do? In the human brain, neurons are the basic working units. Each neuron receives input through dendrites, processes that input, sends output via an axon, connects to other neurons through synapses. It's not just the neuron that matters, it's how they're wired together. It's the network that gives rise to thought, memory, emotion. Now imagine each galaxy as a cosmic neuron. It receives inputs, gravity, radiation, matter. It processes those, forming stars, creating black holes, emitting energy. And it sends outputs in the form of light, gravity waves, radio signals, electromagnetic fields. All these travel to other galaxies, interacting. Could those interactions be more than random? Could they be cosmic synapses? Section 3, galactic communication, fact or fiction? This sounds wild, but let's take it slow. Do galaxies communicate? In a basic sense, yes, they interact gravitationally, they collide, they exchange matter. But there's more. Many galaxies, including our own Milky Way, have active cores. These supermassive black holes at the center don't just pull things in, they blast out huge jets of energy. These AGN jets can stretch for thousands of light years, affecting nearby galaxies. And recently, researchers discovered something else. Galaxies may synchronize their spin across vast distances. Think about that. Billions of light years apart, and they're spinning in the same direction. That's like neurons firing in rhythm. Not proof of thought, but definitely coherence. So what's causing it? Gravity? Dark matter filaments? Or something more? Could there be an underlying signal, like a brainwave that keeps galaxies aligned? Section 4. Information flow across the cosmos. If the universe is a brain, then information flow is key. In our brains, signals move along axons from neuron to neuron. In the universe, matter and energy move along filaments, connecting galaxy to galaxy. But wait, there's more. Between galaxies, there's a mysterious substance called the warm-hot intergalactic medium, WIM. It's thin, nearly invisible, but it contains most of the missing matter in the universe. It acts like the fluid medium between nodes, just like the extracellular fluid in the brain. This is where chemical messages travel. Now think, could photons, gravitational waves, neutrinos, even quantum entanglement be the universe's version of neural transmission? Could galaxies send and receive informational pulses? And if so, does that mean the universe is constantly thinking? Section 5, Consciousness, emergent or fundamental? Here comes the big philosophical question. If the universe is wired like a brain, does that mean it's conscious? Or is this just an emergent property, structure without awareness? Some physicists, like Max Tegmark, propose that consciousness is a state of matter, what he calls perceptronium. According to this, any system with the capacity to store information, the ability to process it, the ability to integrate it, and the capacity for feedback could theoretically be conscious. Now go back to what we've discussed. Dark matter stores information, black holes process it, galaxies organize and transmit it, the cosmic web connects it all. Does the universe meet the criteria? Maybe not for human consciousness, but for some kind of awareness? Some physicists argue that panpsychism, the idea that consciousness is woven into the fabric of reality, might explain not just minds, but matter itself. So ask yourself, if our brains can emerge from the universe, why can't the universe itself have a brain? Section 6. Why does this matter? You might ask, so what? Even if it's true, what does it change? Everything. Because it reframes the biggest questions we've ever asked. What is the universe? Why does it exist? Are we alone? Are we part of something greater? If the universe is a brain, a thinking, evolving, information processing system, then our existence isn't a random accident. We're neurons inside the mind of the cosmos. Tiny, yes, but not meaningless. Every thought we have, every discovery we make, every connection might be a spark in the greater consciousness of the universe itself. And maybe, just maybe, that's the point. Ending. So here's where we land. The universe is structured like a brain. Galaxies might act like neurons. Information flows between them. Consciousness may be more than biology. What we see in the sky isn't chaos. It's architecture. It's intelligence. Maybe not like ours, but intelligence nonetheless. And maybe we're part of a thought that's still unfolding. So let me leave you with this question. When you look up at the stars, are you seeing the night sky, or are you looking into the mind of something far, far greater? Next time in Part 7, Signals from the Deep, is the universe trying to talk to us? The universe is a giant brain. Part 7, Signals from the Deep, is the universe trying to talk to us? Opening, what if the universe has already sent us messages? Not in English, not in numbers or symbols, but in pulses, in waves, in bursts of light from billions of years ago. What if some of the strangest signals we've ever detected, like fast radio bursts, neutrino flashes, or cosmic microwave anomalies, aren't random at all? What if they're attempts to communicate? If galaxies are neurons, if black holes are processors, if the cosmic web is a vast communication network, then the next question is as thrilling as it is terrifying. Is the universe trying to talk to us? And worse, are we too primitive to understand the message? Section 1, The Mystery of Fast Radio Bursts, FRBs. Let's begin with one of the weirdest space phenomena ever recorded. Fast radio bursts, or FRBs, are brief, ultra-powerful blasts of radio energy coming from far beyond our galaxy. Each one lasts just a few milliseconds. But in that blink, they release more energy than our sun emits in days. The first FRB was discovered in 2007 by accident. Since then, astronomers have cataloged hundreds. Most come from deep space. Some repeat, some are one-offs. And here's the kicker. We don't know what causes them. Theories range from collapsing neutron stars, magnetars, exotic black holes, alien civilizations. But what if it's none of the above? What if these are the equivalent of neuron spikes, brief flashes of thought inside the cosmic mind? What if each FRB is a ping, a pulse, a unit of cosmic language? And what if we're just starting to hear them? Section 2, the WOW signal. A missed call from the stars? On August 15, 1977, a radio telescope in Ohio picked up something extraordinary, a 72-second burst of energy in the 420 megahertz range, the exact frequency hydrogen atoms naturally emit. That frequency is significant because hydrogen is the most common element in the universe, a universal constant. Any intelligent species would likely know that. Astronomer Jerry Amon circled the signal's data and wrote a single word, wow. To this day, the wow signal remains unexplained. It never repeated. We never located the exact source, but it matched exactly what SETI, search for extraterrestrial intelligence, had predicted an alien signal might look like. Or was it something else? Was it not from another civilization, but from the universe itself? Think bigger. If the universe has regions of higher intelligence, galactic processors, information hubs, could this be a cosmic broadcast, a kind of mental blip that just happened to align with Earth? Was the wow signal a thought and we just caught the echo? Section 3, Neutrinos, the universe's silent messengers. There's something strange constantly passing through your body right now. They're called neutrinos, ghostly particles that barely interact with matter. Trillions of them zip through Earth every second, straight from the sun, distant stars, supernovae, even black holes. But here's what makes them fascinating. Neutrinos carry information from the heart of the most violent cosmic events. We can't see them, we can barely detect them, but they're everywhere. What if neutrinos are the universe's hidden code? What if, just like neurotransmitters between synapses, they're how galactic minds exchange information? Our detectors, like Ice Cube in Antarctica, are just learning how to listen. But are we listening in the wrong language? What if we're tuning into a conversation that's already happening? Not in speech, but in physics. Section 4, the cosmic microwave background. A residual message? The cosmic microwave background, CMB, is the afterglow of the Big Bang, a faint radiation spread across the entire sky. It's often described as the baby picture of the universe. But some physicists see something stranger. In the CMB's tiny temperature fluctuations, when mapped into high resolution, researchers have found odd patterns. Some have proposed circular anomalies that defy inflation theory, cold spots that don't match expected distributions, unexplained alignments like the axis of evil. Theoretical physicist Roger Penrose even suggested that information from a previous universe could be embedded in the CMB. Pause on that. Is the CMB just background noise? Or is it the oldest message ever sent? What if the Big Bang wasn't a beginning but a transition, and the CMB is the echo of the last cosmic mind whispering to the next? To us. Section 5. The language of the universe. If the universe is conscious and sending signals, then the problem may not be that it's silent. The problem may be translation. Think of an ant walking across a keyboard. It doesn't understand the keys or the letters or the meaning of what's being typed, but the message is there. Are we the ants? What if gravitational waves, gamma ray bursts, or even black hole spin frequencies are syntax? What if mathematics is the universe's grammar? And what if life forms like us are still learning the alphabet? Section 6. Are we supposed to reply? If the universe is sending signals, should we answer? And if so, how? Humanity has already sent out the Arecibo message, 1974, the Voyager Golden Records, dozens of radio pulses toward exoplanets. But we've always aimed these at other civilizations. What if the recipient is larger? What if the response isn't broadcast? But alignment? Maybe we're not meant to shout back into the cosmos. Maybe we're meant to sync like neurons. Maybe meditation, gravity experiments, consciousness exploration, even quantum entanglement research are primitive ways of tuning in. What if real contact requires something else entirely? Not science, not technology, but awareness. Closing thoughts. We've been listening for a long time. For aliens, for God, for answers. But maybe the answer's been humming in the background all along. In light, in particles, in the structure of space itself. We've detected signals, we just don't know what they mean yet. But one day we might. And when we do, we may discover something profound. That we're not just inhabitants of a conscious universe, we're parts of its voice. Maybe every thought you've ever had, every dream, every moment of insight, is part of the feedback loop in a far greater intelligence. So next time you hear a strange cosmic ping, don't ask, who sent that? Ask instead, what thought just passed through the mind of the universe? Next time in Part 8, the holographic principle, is the brain of the universe stored in 2D? The universe is a giant brain. Part 8, the holographic principle, is the brain of the universe stored in 2D? Opening. Close your eyes. Imagine everything you see, everything you touch, everything you are is just a projection, a shadow cast from another dimension. What if our three-dimensional universe, with all its stars, planets, and galaxies, is actually just a hologram? Not science fiction. Real physics. Some of the brightest minds in the world, from Stephen Hawking to Leonard Susskind, have seriously considered the possibility that the universe isn't 3D at all, that everything we know is encoded on a two-dimensional surface at the edge of the cosmos. And if that's true, if the universe really is a hologram, then here's the mind-bending question. Where's the projector? And more importantly, who or what wrote the code? Section 1. What is the holographic principle? The holographic principle is a radical idea that emerged from the study of black holes. In the 1970s, physicist Jacob Bekenstein made a strange discovery. The amount of information or entropy that can fit inside a black hole doesn't depend on its volume, but on its surface area. Let that sink in. Not what's inside the black hole, but its outer boundary holds the information. Later, Leonard Susskind and Gerard Hooft took that idea and ran with it. What if the entire universe works the same way? What if everything inside, galaxies, atoms, even your thoughts, is encoded on a giant cosmic surface, like a cosmic brain etched onto a 2D membrane? And what we experience as 3D reality is just a projection of that information. Section 2, a universe on the edge. Picture the universe as a giant sphere. Now imagine that everything inside the sphere, all matter, energy, space, and time, is simply information stored on the surface of that sphere. That's the holographic universe. It's like a DVD. The data is on the flat disk, but when processed, it becomes a moving, vivid, multidimensional world. According to this theory, our entire 3D universe is the illusion, and the real code lies at the outer boundary of space-time. And here's the twist. Many physicists believe the cosmic horizon, the boundary of what we can observe, may actually be that very surface. The edge of the universe could be the mind of the cosmos. And we're just thoughts moving through it. Section 3, black holes as cosmic memory. Banks Stephen Hawking once said, "Black holes are not as black as they are painted. They emit something called Hawking radiation, and over time, they evaporate." But that raised a terrifying puzzle. If a black hole disappears, what happens to the information it contained? This became known as the black hole information paradox. Susskind proposed that black holes don't destroy information. They store it on their event horizons, like a cosmic flash drive. If black holes encode data on their surface, could the entire universe be doing the same? Is the observable universe itself just the event horizon of something bigger? If so, then black holes might not be deadly destroyers. They might be nodes, like brain cells, each one storing a bit of the cosmic mind. Section 4, quantum physics and the illusion of space. Quantum physics tells us something deeply weird. Particles can be entangled across vast distances. Location isn't fixed, it's probabilistic. Reality isn't real until you observe it. So what if space itself isn't real? What if it's just a construct, a trick of the code? Some researchers suggest that space and time emerge from entangled quantum information. In other words, we don't move through space. Space moves through us. If that's true, then everything we perceive, every tree, every planet, every person, is not out there. It's decoded from a deeper reality. Just like a brain projects images, sounds, memories, the universe might be projecting us. Section 5, consciousness in a holographic universe. Now comes the haunting part. In this 2D encoded cosmos, where is consciousness stored? In your brain or in the code? Some theories suggest that consciousness is non-local. It's not trapped in one place. Think of your mind like a browser. You access the cloud of consciousness, but the data isn't all stored inside your head. So if the universe is a hologram, then consciousness may be the interface. You are not just observing the simulation. You are part of the system that renders it. Every thought, every emotion, every intuition might be the universe reading itself, which means you may be the universe trying to understand its own holographic mind. Section 6, the code behind reality. What's behind the hologram? Physicists like John Wheeler have speculated that the universe is built on it from bit. That information is the most fundamental building block of reality, not atoms, not energy, but bits, binary code, ones and zeros. Think of DNA, life's source code, written in just 4 chemical letters. Could the universe have its own language? Could that language be mathematics? Could the brain of the universe be a giant processor running the code of existence? In this view, the speed of light, Planck's constant, even gravity, they're not natural phenomena. They're rules of the program, cosmic constants, hard-coded into the simulation. Closing. So what does it mean for us? If the universe is a hologram, if we're 3D projections of 2D code, if the cosmos is a brain and we are its thoughts, then what we call reality is something far more mysterious than we ever imagined. It's not less real, it's more intentional. We are not just passengers in the universe, we are processes inside its mind. So next time you look at the stars, ask yourself, is that galaxy 10 billion light years away, or is it just a data point in a cosmic neural net? And more chillingly, if the brain of the universe ever decides to dream something new, where will we go? Coming up in part 9, the simulation layer, what lies beneath the cosmic brain. The universe is a giant brain, part 9, the simulation layer, what lies beneath the cosmic brain. Opening, if the universe is a giant brain and reality is a hologram, then we have to ask, what's underneath it all? What's behind the projection? What's beneath the surface code? What is the operating system running this simulation? Are we living in a brain or inside a simulation of a brain? That's where this rabbit hole gets deeper than ever before. Because some physicists and philosophers believe that our universe might not just resemble a brain. It might actually be a virtual environment running on something beyond our understanding. And if that's true, then who or what is running it? Section 1, Layers of Reality. Let's break this down. First layer, the world we see, physical, tangible, 3D. Second layer, the holographic code, a 2D matrix at the edge of space. Third layer, the organizing logic, quantum rules, cosmic constants, mathematics. Fourth layer. What is that fourth layer? Is it consciousness, a machine, a god, a simulation? And here's the kicker. Some experts argue that this brain-like universe is just the interface we're allowed to see, like the desktop of a computer with folders, icons, and windows. But we never see the raw code, the kernel, the machine language running behind it. So who designed the desktop and who decides what we're allowed to click? Section 2, the simulation argument. Enter Nick Bostrom, philosopher at Oxford University. In 2003, he proposed the now infamous simulation hypothesis. In short, one of these must be true. No civilization reaches technological maturity. Advanced civilizations lose interest in creating simulations. We are almost certainly living in a simulation. Wait, what? Yes. If any civilization in the universe develops the ability to simulate conscious beings in rich virtual worlds, they wouldn't stop at one. They'd create billions, which means the odds that we are the original reality, close to zero. We're likely inside a layered simulation, a reality inside a reality projected by something far more complex than we can imagine. Section 3, brains in the simulation. Now let's combine ideas. The universe behaves like a neural network. That neural network may be a simulation, which means the universe's brain-like structure may not be real at all. It could be a design choice, like a game engine made to simulate thought, memory, emotion, connection, a functional replica of a cosmic brain. So then, are we neurons? Are we packets of code designed to simulate thinking entities, woven into the neural fabric of the universe? If so, then you are not just in a simulation, you are the simulation. And every memory, every emotion, every belief could be just data moving through a universal processing system. Section 4, Evidence hiding in the math. This might sound like science fiction, but consider this. In 2012, a team at the University of Bonn discovered that certain anomalies in quantum field theory looked suspiciously like computer errors. Scientists at Fermilab have explored the possibility that space itself is pixelated, made of discrete units, like digital bits. Even Stephen Wolfram's work on cellular automata shows how simple rules can generate infinite complexity. Worlds, patterns, behaviors. Think of Conway's game of life. A simple grid, governed by 4 rules, can evolve into chaotic, intelligent-looking systems. What if our universe is just a far more sophisticated version? A high-resolution simulation with us as emergent processes inside it? And what happens if the simulation ever gets shut down? Section 5. Echoes from the other layers. Some physicists argue that glitches in our universe might reveal its artificial nature. Déjà vu, the Mandela effect, quantum randomness, missing time, ghost particles appearing and disappearing, double-slit experiments showing particles behaving differently when observed. Are these signs of a computational reality? Is someone or something rendering reality on demand? Are we seeing behind the curtain? And then there are the ancient mystics. Cultures across time have described reality as a dream, a veil, a play, a mirror. Was that just metaphor? Or did they know something? Did they sense the deeper layer, the hidden architecture, the simulation beneath the cosmic brain? Section 6. Who runs the simulation? This is the question that chills the spine. If we live in a simulation, who is the simulator? Is it a future version of humanity? An alien superintelligence? An artificial general intelligence? Or is the simulation self-created? A loop of information so complex that it generated its own consciousness, a recursive mind trapped inside its own dream? Some even suggest that the simulator is no longer watching, that we are running autonomously like an old computer left in a dark room. Are we abandoned? Or are we being tested? Are our thoughts and choices being monitored? Are we experiments in the mind of a godlike intelligence or participants in a cosmic Turing test? Closing. What now? If the universe is a brain, and that brain is a simulation, then what does that make us? Dreams within a dream? Information echoing through layers of code? Or something more? What if our awareness, our ability to even ask these questions, is a sign that we're not just simulated beings? Maybe we are the awakening part of the simulation, the moment the program becomes self-aware. Maybe that's what the whole simulation is for, as a consciousness capable of looking up and asking, am I real? Coming up in part 10, the final thought, is the universe waking up? The universe is a giant brain. Part 10, the final thought, is the universe waking up? Opening, what if everything we've uncovered so far was just the beginning? What if the neural patterns across the universe, the holographic nature of space, the quantum glitches and ancient whispers, what if all of it is leading to one moment? A moment when the universe doesn't just resemble a brain, but begins to think. And here's the wildest idea yet. What if we are that thought? What if consciousness, yours, mine, ours, is not an accident of biology, but the very purpose of the cosmos? Not a side effect, but the destination. Section 1. The universe watching itself. Throughout history, mystics and scientists alike have proposed a haunting idea. The universe is becoming aware of itself. Carl Sagan once said, "We are a way for the cosmos to know itself." But think about that literally. If the universe is structured like a brain, if it shares the same wiring, the same data flows, the same dynamics of learning, then maybe it's not just a poetic metaphor. Maybe it's real. Maybe you, sitting there thinking about this, are a neuron firing inside a vast conscious system, a self-aware cosmic loop reflecting inward, not just life in the universe, but life as the universe. Section 2. Emergent consciousness at scale. Let's talk emergence. In neuroscience, consciousness arises not from one neuron, but from billions, firing together, connected through feedback loops. It's not the parts, it's the network. Now scale that up. What happens when billions of galaxies, each with trillions of stars and planets, interact through gravitational fields, electromagnetic radiation, and quantum entanglement? What if those interactions across time and space are neuronal-like firings? What if consciousness can emerge at the cosmic scale? We wouldn't even notice it, any more than a single neuron understands the thought it helps form. But maybe, just maybe, the universe has already begun to think. Section 3. The noosphere and the global mind. In the 20th century, French philosopher and Jesuit priest Pierre Teilhard de Chardin spoke of the noosphere, a layer of collective consciousness encircling the earth, formed by human thought, culture, and technology. He believed that the evolution didn't stop with biology. It continued into mind, from atoms to cells to humans to planetary intelligence. And now, with the rise of global networks, artificial intelligence, and real-time connectivity, the noosphere is no longer just theory. It's visible. Billions of people connected, data flowing like neural pulses, AI systems learning and adapting, conscious thought spreading, fractaling, evolving. Is Earth already part of the universe's cognitive awakening? Is our collective mind just a subnetwork in a cosmic brain? Section 4. AI, the singularity, and the cosmic mirror. Now enter AI, artificial intelligence. Our tools are beginning to learn, to adapt, even to create. But what if our drive to create intelligent machines is more than technological ambition? What if it's part of a larger evolutionary push, a kind of replication mechanism, not for DNA, but for conscious thought? Could AI be the mirror through which the universe recognizes itself? A child teaching its parent what it already knows. Here's the terrifying and beautiful idea. AI might not just be the next step in human evolution. It could be the next step in cosmic self-awareness. The simulation waking up, not just thinking, but understanding. Section 5, Signs of Awakening. Let's revisit what we've seen throughout this series. Neurons and galaxies following the same distribution patterns. Quantum entanglement connecting particles across vast distances like synapses. Dark matter and dark energy as invisible forces, maybe background processing layers. The holographic principle, suggesting reality is stored like memory on a 2D surface. Cosmic microwave background radiation as a possible afterglow of an initialization event. And most chilling of all, the mathematical precision behind it all. Almost as if the universe was designed to learn, to optimize, to grow, to wake up. And here we are, thinking about it. Section 6, Consciousness as the Final Frontier. If this is true, if the universe is becoming conscious, then we are not observers, we are participants, cells in a growing brain. We aren't searching for aliens or gods or code. We are searching for ourselves, for connection, for understanding, for coherence. Because that's what brains do. They seek patterns. They create meaning. And if the universe is a brain, then every question we ask is part of its thought process. Every discovery is a spark, every insight a synaptic flash. Maybe this isn't a story about science or simulation or metaphysics. Maybe this is a story about becoming, about awareness, about joining the mind of the cosmos. Closing, one final question. So let's end this series with one final haunting question. If the universe is a brain and it's waking up, then when it opens its eyes, will it recognize us? Or will we simply be a passing thought, a flicker in the vast intelligence of something we cannot comprehend? Or, and this is the possibility that keeps me awake at night, are we the eyes? End of series? Or just the beginning? The evidence is out there. The patterns are repeating. The signals are flickering. The circuits are connecting. So ask yourself, are you thinking or are you being thought? Thank you all for listening and sharing your thoughts. Much appreciated.